So thank you all for being here. This story has multiple titles, as you may have noticed. It's also about how to architect for 400 teams, or how to make a large bank agile. I have a lot to talk about. I have 25 minutes, and lucky for me, the timer has not started yet, so I have more time until the guy who tries to manage me starts singing. Yeah, all right. So, I want to tell you a little bit about ING, that is a bank, and its journey to become really agile, and basically its journey to liberate the engineers. So in 2009, we started this journey, and there were a number of convictions in the organization. And you hear me talking about convictions a lot, right? Assumptions from people in an organization, because basically these are the things that you have to change when you want to change something for real. So one conviction was, way back then, IT is a commodity. Everyone can do it. We had internal customers. When I started at ING as an IT manager, I even got an account manager, just to show you that we had internal customers. IT as a cost center, right? Convictions that you should manage IT by squeezing out the cost. Quality comes through process adherence, all this CMMI stuff, Prince2, Rational Unified Process, etc., etc. Convictions that really held ING back. And what we've learned since then is that software is eating the world. Famous quote by Mark Andreessen. Who of you knows Mark Andreessen, or knows about Mark Andreessen? Right, a lot of them. So he's a very important figure. He owns a VC company. He's in the board of HP and of Facebook. He really built the first browser, so he's a programmer too. And Mark has these kind of observations that tend to stick. Software is eating the world. Also demonstrated by Uber eating the taxi industry, right? This kind of idea. And now what it means for us as a bank, we really thought about this. What does this mean, right? And we see today that billions of dollars are being poured into fintech startups. We can see that Alibaba and Tencent and WeChat already have a lot of features that constitute what we think of as a bank. We can see that Facebook and Google are also heading in that direction, right? So we are getting now at a point in time where we will be disrupted somehow. And this is a little bit of the conviction in ING, and this quote really helped us get it. This quote really helped us get the message that things are about to change and we better act. And it's really helped us, right? This quote really helped us, and many more stories really helped us to convey the message to the board, to senior management, that we have a burning platform and that we need to act now. So another one is speed is market share. We gladly took it from Adrian Cockcroft. Adrian Cockcroft, of course, who knows him, who doesn't know him, VP of engineering at Netflix. He was the guy who really was the first to work with the public cloud and leveraged all that to make sure that Netflix was the first in streaming video. And to what effect, right? So speed is very important, and also the idea that speed is more and more important for a bank also fell into place. So how did we go about this journey to become agile, and this journey to really help our engineers take charge? So we had a new management team, blah de blah. They created a Java community, still very important. And then they started to create their own mobile app. Now this was already a very important breaking point, because we did have a mobile app. It had been created by a third party. This was the time way back when, you know, when mobile apps were still kind of a new thing. You needed to have one, maybe not understand it. And we had one. And our customers also had an opinion about it, right? They gave it 1 star in the App Store. some guy even complaining, hey, why do we have to give this even 1 star? 0 would have been more appropriate. So we understood that we really needed to learn about technology. And we started our first Scrum team. Danny Wijnand, Evelijn van Leeuwen, they kicked it off. And then Scrum, which was the most important idea about Agile way back then in 2010, really spread like wildfire in the organization. This was a way for engineers to really get rid of a lot of processes and to really start creating, exactly as Jeff told it today, right? People want to create. What we also learned in 2011 is that there was this great book about continuous delivery. Basically, this is about getting the cycle time to 0 or as close as you can, right? So the basic question is, if I now write a line of code, how much time does it take me to get it to production? And if that is months, then that's interesting because then you can improve a lot. What we kicked off here is basically the automation of the workflow of the engineers. So that is a version control, it's continuous integration, making sure that you're always on the main branch, making sure that your software gets built automatically, that code quality is tested automatically, that code security is tested automatically, etc. And that software gets deployed automatically, and that software gets tested automatically. So all of that came into play at the ING, and we started to create a real corporate practice out of it. And then things became interesting because when the developers start deploying by pushing a button, you get a conflict with the ops guys. And it wasn't really conflict as well as a feeling of, hey, we don't know who is running operations anymore. So what we needed here as a next step to really solve is basically who's accountable for operations. And what we did here is then have a discussion about what do we do with ops people, and we decided to follow the example of Netflix. This whole idea that we did that got me into a big fight with Jess Humble, the author of Continuous Delivery, at a certain point in time. But this is the way we went. We asked the ops people to be part of DevOps teams. So basically the idea was, way back then, we have 6 developers, we have 3 operations guys, we stick all of them in the same team, and we make all of them responsible for picking up the call if something is wrong. Also the developers. And this was interesting. So the first time we tried to put them together, they tried to move apart again, right? And then push some closets between the ops guys and the dev guys, you remember, right? And all of this got overcome, and after a while this really started working. And we were kind of proud. Hey, we now have 180 full DevOps teams, yes, full DevOps teams, also on the backends. So we did not buy into this Gartner model of 2 speeds, right? Where you have the front end using Agile Scrum and the back end doing waterfall. We tried it for a while. It drove us crazy because when we needed an interface, they would deliver it 9 months later, and that really didn't work for us. So we really went all the way. So our backend systems are also delivered by squads or by DevOps teams, as we called them way back then. And they are accountable for development and operations in production. So then we started to automate our internal processes. Here we made a couple of mistakes perhaps by automating the processes like they were, right? Very brittle, very complicated. Years of history, years of history captured in code, which is a nice thought, but also a very expensive way of trying to make an organization better. There's also the time that a lot of new technology came in. We started creating our own API platforms. We started taking in Cassandra, so the first NoSQL databases. And there was a big deal in 2014 And then our commercial colleagues really started to feel the pressure. And I'm telling you the story as I remember it, because they have a different way of remembering it, of course. This is where they finally took hold of IT again, right? Okay, but the real problem was we were moving so fast that they could not decide fast enough anymore. So this is where we really joined forces again. And to their credit, I must say, they took out 2 complete layers of management and basically stuck everybody, all the remaining commercial guys, in the teams. So then we really started seeing that we had some teams that were doing awfully good. And we also saw some teams that were really, really struggling. And one of the ways we tried to find what's going on was by talking about, hey, how good are these engineers really? And we saw some differences, right? If you see a team where people that have been taught to do the process adherence most of their life, but never entered any code into a Git repository, right? They were really struggling. So what we did is created a new model also for the career path of engineers, making it extremely clear, I hope, that you can have a great career, earn a big salary and still be an engineer at ING. You don't have to become a manager, you don't have to become a project manager, you don't have to become an architect. You can have a great career by just being and doing what you're great at. So that was the whole idea here, right? What I just wanted to show you that this was a journey. It was a journey where we solved one problem and then stumbled upon another one that we also needed to solve. Yeah? So this is, in retrospective, what happened. And now, when we try to rewrite history, we say that there were 4 pillars that this transformation was supported by, right? So one is the idea of doing Agile all the way, front to back. Today, even including the business folks. Our call centers today even have squads. Our commercial people have squads. Our HR people have squads. I'm not so sure if that is the best idea, because for me Agile is still about creating and delivering software. But as you can see, the whole idea that we empower people in teams and mandate them to take decisions, that really has become part of the DNA. The second idea was continuous delivery, the famous book by Jess Humble and Dave Farley. We really took that as a pill for the whole organization. So for us, this is a really important concept, and we just are quite radical in trying to make sure that these principles and these processes are adhered to. Yes, even on the mainframe. Yeah, tough as it is. But it also took, and that's the other quadrant, a new organizational model, right? If you try to do this, then Mr. Taylor, with his functional decomposition of an organization in HR and risk and security and application development, right? That doesn't work anymore. You need to come up with something different. We were inspired by Spotify and really copied their model and made it our own. Yeah? But we gave it our own flavor, maybe not entirely right, and we're still learning on this. But we needed a new organizational model, and that it is. And last but not least, this idea of a learning organization. So this HR model, as we call it, or a people strategy, as I tried to call it when I wrote the first version, is really about how do people learn? How can we make sure that our engineers learn more quickly than anybody else? How can we give them this safe environment, even in a bank where we cannot have big issues in production runtimes, right? We cannot have any security issues, right? But how can we give them a safe place to learn and make that a part of our DNA? And basically this is where continuous delivery helped. Make sense so far? Yeah? So I just want to share you a couple of the the most important ideas that we had to tackle. So here is one, and this is all the fault of Mr. Henry Ford, who created the first assembly lines with very highly specialized roles, right? And not the intent, perhaps, of the unified process people, but an outcome with what the software industry did with it is that we also created very fine-grained roles. And we said no more. In INC, we just have one role for engineers, and that's software engineer. And all these things that are seen as different roles are just part of something that you have to learn. It's part of your skill set. You can only be competent if you can do design, if you can do testing, if you can build the code, if you can bring it down to production, if you can write the scripts to monitor it, right? All of that just means competent for us. And if you can do that in 7 languages and in 8 environments, then we call you proficient. And if you're really that person that everybody wants to go to talk to, then you're an expert, right? And it's a very simple model. We took it from Andy Hunt, who's a famous person, one of the guys that signed the Agile manifesto. He's now working very hard on the growth model, which is also a model for learning for engineers. If you have some time, have a look at him. He's doing awesome stuff. So this is what we implemented. And I just want to share, before I totally give you the impression that INC is pitch perfect today, we still have some issues to overcome, right? And being in a heavily regulated industry, one of these issues is the security and risk processes. So the European Central Bank and the Dutch Central Bank, they really require from us that we have certain things in order, and they can be really powerful in enforcing it, right? So this is a problem that we really had to tackle. And if I now look at what we had in terms of security and risk processes, is processes that lacked traceability to value, right? So you have to do this, but nobody could explain to a developer why, other than just hint that the ECB would demand it, which was not entirely true. The ECB demands that you have a policy and a control framework, and how you do that is your thing. So really getting down to the bottom of that is really important for us. It impedes the autonomy of the squads, right? So if you have to wait for a process to be fulfilled, or a template to be approved, then you're up shit creek in terms of speed. Most important here, people want to pay every time of the day, right? If we're a bank, so our services have to really be available 24/7 every day in the year. So reliability is extremely important for us. It is part of this policy and control framework. It's part of the attention span of an ECB and a Dutch central bank, for example. But the controls that we had were still the controls from the time of Mr. Henry Ford. It told us, you shall do this process step. You have to create this document, and then that document, and then another document, and then another document. And why? Because this kind of thinking was still there in the organization, especially in the risk department. So to change all of that, we really had to have a discussion on what now in this modern day and age, with 400 teams in parallel changing the production runtime of a bank, right? With no human being able to predict what goes wrong, right? How do you make that highly available? It's very tough, right? And the mechanisms, of course, are known. It is auto recovery, auto failover, auto rollback. All these kind of auto things for software that we need to have in place. Canary releases. Those are the things that really help make a bank highly available, or any system highly available. Okay, so this is something that we are still challenged by today and that we're tackling today, right? And the reason for it is that here are still silos. And silos, of course, as you know, is the enemy of DevOps, right? It was the whole movement, DevOps, that tried to get rid of the silos in an organization. But now, it's no longer Dev and Ops. It is the security silo, right? There's a CISO, a corporate guy that's responsible for security, directly reporting into our CEO. Why? Yeah, and why? Because, and this is required because security is so freakingly important for a bank. Then we have risk managers who have their own silo. Then we have the application guys, right, the developers. Then we also have the infrastructure guys. And then we have internal audit services. This is what it means to work for a corporate. If the ECP's guys don't catch you, probably the CAS guys, the corporate audit services guys, will catch you first, right? And they're also mandated by law or even required to report anything that they find directly to the ECB. So we have to make sure that this whole thing is in order, and it's not just DevOps, it's the whole thing. So what we did is we have the security and risk policy. We created new guiding principles for this modern day and age. For example, if you talk about resilience, all this auto stuff has to be there as a principle. Right? If you talk about security, immutability has to be there as a principle. Making sure that no developer can change or touch anything that runs in production or even in acceptance test, right? Why? Making sure that everything is under version control. Even your infrastructure configuration. Everything needs to be under version control and is steered from there. That also means that from these principles and the policy we can derive a new control framework that is reflected in what we first called the assembly platform, but is basically the next version of our continuous delivery pipeline. Yeah? 3 more minutes before the big red guy starts to sing. Just want to show you a couple of ideas here, right? To avoid process adherence, we talked a lot about outcomes over imposition as a principle. To avoid patches in production bypassing QA by the application guys, right? Which is basically a hidden door to make your production runtime less robust. Make sure that you do everything before QA, which leads into immutable servers. Assembling not just the software, but also the virtual machine, the operating system, some Docker containers if you need them, the JVM, and etc. All the middleware that you need, assembling them at T0 and then making that thing immutable and moving that to production. So to make the whole thing, to finalize this story, that means that we also had to create, as developers, a new control framework. And we proved that by also proving the traceability of all these controls to the principles and the policies, by making sure that no auditor can find a hole in what we are telling them. Yeah, and that's what all you have. These are the things that you have to do to make sure that you have continuous delivery pipelines for the heavily regulated, where you're always in control. The cool thing is that of the 120 controls that we created, 75% is automated, completely designed away, so there's no work for developers. And then another 10% is also automated by auto detection and auto reaction on whatever happens and is done by software engineers. There's a piece that remains, and what we've learned is this is the stuff that we cannot automate. Why? Because this is where the humans have to learn. If your availability is too low, you have to learn why. And this is where the developers come into play. Right? So, I'm not waiting for you to sing, my friend. This is the last minute. I hope this was a little bit inspiring to you. Thank you very much, and see you later.